So hello guys, my name is Ganesh. So in this tutorial I'm going to teach you about Catia based software. Almost covered every single tools that I used for part designing and the sketcher. So if any of the tools are not discussed means I will use those tools in the exercises. So now this is all as you are seeing this is a Catia Wi-Fi interface. So you can see here the top left corner there is a start window. After there is a things like this, so you can call them as a workbenches. So every workbench serves different purpose, so mostly we use mechanical design workbench. So in that mechanical workbench there are sub workbenches are there, so part design, assembly design, sketcher and drafting. So by generally if you want to create a 3D model, we need a 2D sketch. By giving the 3D features to that 2D sketch we can get a 3D model. So it is okay. So first step is drawing the 2D sketch. So drawing that 2D sketch is done in the sketcher workbench. So here you can see there is a sketcher workbench, and if you want to give the 3D features, then it will becomes a part. So which the tools for the giving the 3D features is lies in part design. And if you are completed the parts and want to assemble, the features for relating to the assemble is existed in assembly workbench. So first I will start with the sketcher workbench. As you can see there is a sketcher, and drafting workbench is also there here. So we will discuss drafting means getting a 2D diagrams, 2D views from the 3D object. That means drafting. So which is a concept that we discuss later, not in this video. So now our discussion will only restrict to this sketcher and part design. Now clicking on the sketcher, you have to give the name of the sketch before this. After clicking on OK, it will take us to sketcher workbench. So see here it is not a sketcher workbench, so it is a sheet metal workbench. So if you want to draw a sketch, here you can see there is a feature that is this one, and it takes us to a drafting environment. So here there are two options are given, sketch and position sketch. Both are different, both are used for the same purpose but serves as a different. So I will discuss the difference between the sketch and position sketch later in this video. So first I have to choose which type of sketch I want to do. I am choosing the sketch and I am choosing the plane. So choosing planes is also important. So I have chosen the front plane. So after that, so here see here it is a sketcher workbench. How can you identify it is a sketcher workbench? So on the top toolbar you can see there is a profile toolbar, and there are tools required for drawing the sketch are exist. So that is a profile toolbar. So it is a sketcher workbench now. So if anything is hidden means right click on the space, you can enable them. So the most important toolbars we discuss in this workbench is view toolbar and the sketch toolbar, and it is a profile toolbar, and it is a I don't need this thing. Okay. So this toolbar is constraint toolbar. So now it is okay. So this is about the sketcher workbench. I don't want to use the every single tool here because the video will get lengthy. We will use this every single tool while doing the exercises. So I don't want to explain every single tool here. So this is a introduction to this sketcher workbench. Now I'm lefting that. Now we'll go to this part design workbench. So I already told you first step is sketching and the second step is giving the 3D features to the 2D sketch. So now we are getting into this giving the 3D features, that means part design. So it takes some time. So while switching between the workbenches it will take some time. So here it is a part design workbench. How can you identify that part design? So 3D features are available here, that's why it is a part design workbench. The most important toolbars here we discussed is sketch based features here, that is. So here insert tab and insert menu, here you can see sketch based features, dress up features, transformation features. So all these are existed here. So as you can see most of them are not highlighted because the unhighlighted tools that we can only use it on 3D parts. Here there is no any 3D part, that's why they are not highlighted, but some features, 3 features are can be used now. So these are for giving the basic 3D models. So first I will start with this one, pad tool, and then pocket, and pad, revolver, multi-section, and a rib. These 4 features that can be accessed right now. So for giving the 3D feature, we need a 2D sketch, already discussed you. So for drawing the 2D, there is a thing like this existed in every workbench. So this takes us to drafting workbench. So now I will explain you about the difference between sketch and position sketch option. So I have selected only sketch and I chosen a plane. So here I'm choosing this normal sketch option and I'm choosing this front plane. Okay, top plane I have selected, so no problem. So let's see, I was drawing a circle here and exiting from this workbench. So there is a symbol here. So see the position of this circle. So see where I have drafted, somewhat like here I have drafted, but it is projected here. So this is a problem with this sketch option. So now I am using the position sketch option. So okay, sorry, escape, choose the position sketch option here, and it is asked you, a window is popped up and it is asked you for the reference. And reference I have taken this front view. Okay, not the front view I have taken the top view, and I'm shifting the axis. So here you can see horizontal place, it is showing the vertical axis, that's why our sketch is differential. We need to change that. I'm clicking on the swap, vertical will be horizontal and horizontal will be vertical. So now I'm reversing the V direction. So now it is okay, our axis system is okay now. So now same thing, I'm taking the circle here and exiting from this workbench. See where I have drafted the thing, somewhat like there, the circle is projected. So this is the use of sketch and the position sketch options. Now I cleared the things in our discussion. So pad, we will discuss about the pad tool. So before that we need a 2D sketch. It is a 3D feature which is only given to the 2D sketch. So for that I need a 2D sketch and I am developing a 2D sketch right now. So see, I have chosen a position sketch option and I am taking some closed profiles. I have taken the profile tool, and I created a closed body, and I am drawing a center rectangle. It is also a closed body, and I am choosing a circle as well, which is also closed body, and I am checking the spline. With that I am making another closed body. So escape, that's okay. So 4 closed bodies are created. Now exit from this workbench. So exit from this workbench. This is for learning purpose only, that's why I have drafted the things like this. So this is okay. Now click on the pad tool. So what is happening here, some thickness is given, the material is adding here, so you can enter the value of that, whatever value you have given. The third, that means 3D feature is happening here, so adding the material. So you can, now you get the idea about pad tool, so which is used for adding the material. Now here you can, our sketch is exited at mid. If you enable the material extend option, both sides will be extended, and if you want difference on both sides, if you want different extensions on both sides, different extrusions on both sides, then you have to select this more feature and untick this mirror element, and on the upper side you can give this 20 mm and the lower side you can give another. So click on the preview. So here you can see on the one side I'm giving, so the plane one side I'm giving 20 and another side I'm giving 50. So see, our sketch is exited here and 20 mm which has given here are exited on the top side, and the bottom side we have given 50. So this is the use of this pad tool. So this is all about this pad tool, guys. Now the next thing is pocket command. So we need a 2D sketch for giving the 3D features. So for that I'm choosing the position sketch option, and I'm choosing the plane on which I want to add the sketch. So I'm cancelling, so I've chosen this surface on the part and surface on the part. So I've chosen this surface for sketching. So here you can see reference as a pad. So click on OK. Now click on OK. So it is take us to sketching workbench. So now I'm drawing a two rectangles here like this. One is a normal rectangle and another one is a aligned rectangle or angled rectangle. So I'm exiting from this workbench. So here see I'm activating this pocket command. So what is happens? So it is removing the material. So one more thing that I forgot here to explain is, so a type, pocket type or a pad type, you can give the dimensions, or else you can choose these 5 types. So in case of pocket, the 5 types will works, but in case of pad, it you need some advanced level product, and then only it will work. So simply I'm giving the dimensions 100. I'm giving that click. So it is removing the material. So pocket is removing the material. So this is the first type I have used, and in the last and in the second up to next option. So this means we have drafted a 2D thing on the one side of the object, and if you select this up to next option, the packet will be takes up to that body only. And if you enable this up to last and up to plane, you have to select this plane, and up to surfaces and up to plane works as a similar. So that's it. So pad and take this sketch and apply up to plane option and select this plane. That's it. Pocket will be generated. So this is a use of this pad and pocket tools. We have explained this both. So now one more thing we need to learn is mouse manipulation. So here you can see a rotate option is there. By clicking on that, you can rotate the object, which is also done by the mouse as well. For doing mouse, you need to click and hold the mid mouse button and click and hold the right mouse button and drag the mouse. So here that's how you can rotate the object. So here circular shaped frame will be displayed in case of, so if you want to zoom, so you can access zoom in and zoom out right from here, or else mouse manipulation is press and hold the mid mouse button and press and release left button, right button, right mouse button, and drag the mouse upside for zoom in and drag the mouse down for zoom out. So this is the mouse manipulation in Catia VFI software. And viewports are there, means by clicking on the view toolbar, 4 separate windows are displayed here. So you can see the 4 side views right from in the one graphic area. So this is a view style now. And the next one is hiding the objects. So here you can see hide and show box is there, tool is there, and if you enable that and click on the product, it will disappear from here. And it is called a specification toolbar, and click on the plus sign. You can see these are the 3D features that are given, and they are displaying like somewhat like in dotted shape. So this means they are hidden. So the hidden things can be visible in sublet area. So that is a snap visible area. So you can unhide the things that are hidden by right clicking on the thing from the specification tool. So I have click on the hide option. So hide it. So hidden things will be appeared in another area that is called snap visible area. So the green background is there. So green background, it means you are in snap visible area. So here you can see hidden things from your design environment. So if I hide the things from here, they will be displayed in our designing. Again, I'm returning to this draft design workbench and I'm choosing this part and I'm showing the option. So here you can have unhided the things that are hidden. So this is a use of this hide and unhide option. So I have chosen the shading with edges view style. So now there is a shortcut. You can set a shortcut. So I will show that one trick. So I'm selecting the object and clicking the space button. So what is happened? The things are hidden. So which are available in this snap visible area. So again I'm selecting the product and I'm clicking the space button. So that means I have set the space button as a hide button. So you can also set that. For that, right click on this empty area and select this customize option window will be pop up like here, and in the commands tab you can here look for the view, and then the scroll down, look for the view, hide and show, and click on the show properties. Here you can see accelerator. So I have chosen the space button as my accelerator, that's why the space button is used as a shortcut key. This is how you can hide the things, and this is how you can choose this hide shortcut key. Till now we have discussed about pad, pocket, and hide and view toolbar. So now it is time to learn about this revolve feature. For applying the revolve feature we need a 2D sketch, and for the defining the 2D sketch I'm choosing this position sketch option, and I'm choosing the plane for drawing the 2D sketch. So now it is take us to sketching workbench. Now I'm choosing the any profile like here, and I'm creating a closed body like here. I don't know the name of this tool, I'm just creating. So this is a tool, okay. So a closed body I have made. So till now I didn't explain about giving the dimensions, so it is now time. So here you can see there is a constraint toolbar, and enable, then double click on that thing and click on the entity for which you want to give the dimension. So it will double click on the dimension, you can edit. So with the constraint toolbar I am giving this every. Now here a sketch tool toolbar you can see grid option is there, snap grid is there. So if you enable this snap grid you can only select this corner point of that grid, so it is a snap grid. So if you are untick that one, you can draw at any space. So this is a use of this snap grid option. So I'm exiting from this workbench and applying this revolve command. So what I have done, I have selected the profile and I chosen a axis, rotation axis. Based on the sketch rotation axis, the component will be generated like this. So this is the use of this revolve tool. So shaft, no, it is not revolve, it is a shaft. Actually another design software it is called revolve tool, and in the Catia it is a shaft command. Now it is added material with respect to a axis and with respect to a sketch. Now thinking about that groove, I am taking a front plane and I am creating a 2D sketches. Like here I am doing the 3D sketches, 2D sketches, sorry. And I'm exiting from this workbench. Now I am applying this groove and I selected this drafted profiles, and what is happening here, so it is cutting the material with respect to the what we have drafted. So I'm switching to this front plane and I'm control Z, it is for undo operation, and control V is for redo operation. So see the difference before and after applying this groove. So this is a, so now you can understand that groove is for removing the material with respect to a rotational axis and with respect to the sketch. So groove and shaft is also completed here. Now hole tool is there. So generally you can make a 2D circle on this pad surface, and I'm clicking on the pocket, you can give this hole, but separately it is given the hole tool. It is because if you want to apply a thread on internal surface of the hole, so in that case you have to use this hole tool only. So I'm clicking on this hole option, hole tool, and I'm clicking any surface. I'm clicking on the hole tool and I'm choosing the point at which I want to make that hole, and it is not properly constrained. I have to constrain that by clicking on this position sketch option. I can constrain that one. So see, click on this, so you have to give the dimension for constraining. So click on this constraint toolbar and click on this point and the line from which you want to give the dimension. So I'm updating it to 25, and so like here I have given the dimensions, I have constrained it, and exiting from this, and I'm editing the diameter of this hole. So hope you already know about this flat bottom and V bottom and the hole. I didn't explain it right now because I will explain them in the following exercises. There are 5 types of holes that you can create in this Catia wave assembly. So we are not generating all types of holes here. So I will explain you in a different video, in a separate video for that. The third window, you can see a thread is there. If you tick on the threaded, you can give this dimensions of the thread. So in here you can give this metric thing or thick. So I'll explain you in a separate video. So I'm taking this 12 and preview. I'm clicking on OK. So now it is OK, but it is too small. I want to increase that size. Double click on the hole. Again the input key is generated and I'm increasing that size and clicking on the preview and OK. Zoom out. So this is how the thread is there, but it is not visible. So this is how you can use this whole tool. Here I'm choosing the position sketch and front plane and I'm making a path like here, and I chosen the corner sketch for smoothing the surfaces. So the thing is, I didn't drafted this path from a plane. So I want to add a plane at the end of this curve. So I want to create a plane. So for that you can create a planes. So you can see here there are a number of things that are available here, every single topic that we discuss in the following exercises. So right now I'm choosing this curve, normal to curve option. So you don't need to select that one, automatically it will take. So here you can see a plane is created at mid. I want the plane at this point. Click on that point, a plane is created here. Now click on this plane and position sketch option. So now you can draft the things that you want on this plane. So I have created the plane only, and I given any dimension for this thing. Double click on that, you can again enter into this sketch. So I'm constraining that them with the proper dimensions and I'm clicking it to 50, enter. Okay, exit from this workbench and use this rib command. Choose the path and the profile. So see how it is generated. So see, this is how the rib tool will works, and it is a solid body. If you want, so now it is a solid body. So the curve is hidden here, that's why it is like here. So I don't want to hide this, I want to unhide this. So I'm clicking on this. So control plus select this line. Multiple, if you want to select the multiple things, you need to use the control key and unhide this thing from here. So it will display on the our working area. So now slot, we'll discuss now about slot. Again you can use the same plane for creating the things. So now I'm choosing the surface of this object for drawing the thing. So you can use this thick profile. If it is a solid part now, but I want to make it as a hollow, you can use this thick profile. So okay, now I want to explain about slot tool. So for that I need to have a 2D drawing. So see, I'm just giving a 2D, I'm just creating a 2D model. I have taken 3 circles like here, and I'm exiting from this workbench, and a path is again hidden. The path for creating this object is again hidden. Go to snap visible area and unhide the thing, unhide this path. Click on the space button, it will hide it. So that's okay. So again click on the snap visible area to exit from that one. So now it is okay. Now click on the slot tool and choose these circles as the profiles and choose that line curve as a path. So now what is happened? So click on OK. So what is just happened? It is removed the material, somewhat like the sketch with respect to this path. So this is the uses of slot and rib tools. And there is another more tools, multi-section solid. So these two tools I will explain you later. So right now I want to teach you about multi-section solid. So click on the position sketch option and create a random figure. So I created a circle here and I'm using the pad tool for extrusion purpose. So I'm updating the length. Okay, click on OK. So now the both sides are circles. So what if I want circle at one side and one side I wanted a triangular shape? Is that possible with this pad tool? So it is not possible with this pad tool. So if you want multiple things, this what I means that unsymmetrical things you have, and you want to create a solid from that unsymmetrical things, then multi-section solid will works. So on the mid of a part I want a circle, and on the upper side I want some other part, and on the one side and I want another shape. Now upper side there is no plane on the upper side and bottom side, so for that I need to create a plane. Click on the plane option and create a plane which is at a distance of 50 from the top plane. So click on this plane option and click on the, so you can see here that type is offset from the plane. So a number of things are there. You can we can use that all things in the following exercise. Now I'm choosing the offset from the plane option and I'm updating the value to 50. Click on enter. OK. The same thing I want on the down side as well. So click on the reverse option and click on OK. So now things are there. Now I'm choosing the position sketch option and upper plane, and I'm choosing the rectangle, center rectangle, like this. OK, click on exit option. OK, now click on the bottom plane and choose the position sketch option and choose a polygon here. So I have chosen the polygon. Click on the exit workbench and escape. So now three things are completed. I want a rectangular shape on the top side and a polygon at the bottom. Click on the multi-section solid, click on the sketches and click on the preview. It is not come, so go to coupling and ratio. Now it is okay. So a product is generated, so which has polygon at the bottom side, rectangle at top side and a circle on the middle. So this is the use of this multi-section solid. So following this multi-section solid removes there, so which is removing the material. So multi-section solid is for adding the material, and more useful features are there. Here you can see edge fillet. So here you can see it is a sharp edge and I want a round edge. So in that case you can use this edge fillet option. Click on give the radius and you can see a round surface is generated. So this is edge fillet, and the edge chamfer option is also there. So in that case you won't get any radius. It is also used for the rounding not rounding. So if it is a sharp edges, you can use this chamfer and fillet options. So there is another tool. So shell is useful. So click on exit. So it is not possible in this case right now. So shell we use the most. So now let me clear all these things. I'm deleting all these things. So now it is okay. So now we will discuss some more features. So till now we created the things not with the proper dimensions. Now take a rectangle, click on this center point and make a rectangle like here. So I'm taking this constraint toolbar and giving the proper dimensions. Now I have created a 2D sketch with the proper dimensions. Double clicking on them, you can edit them. Okay, so now I have a rectangle with the proper dimensions. I click on the exit command. I want to add a material. So what I have to do is I can give this pocket command. So click on the sketch. So now update this. I click at the mirror extend option and clicking on the OK. So now a rectangle with the proper dimensions is created. So already explained you about the hole tool, and I'm making a hole here. Okay, now I'm clicking on the hole tool and I want to constrain them. I want to add it proper dimensions. So click on the position sketch option and I'm enabling this constraint option, and I'm giving the distance between this hole and the edge. So I'm updating the value by double clicking on them. So 100. Okay, I'm giving the dimensions only here. So okay, exit from this workbench and update the hole diameters. So now it is too small, I'm updating that. Okay, so I want that hole to be through hole, so 10 I'm giving. So okay, so it is on the upper side only, so I want it to so already told you about types. There are 5 types of holes are there: simple, tapered, counter Sanko, counter board, and counter board holes are. Here you can choose up to what up to this hole will be. So you can choose the 5 options, and here there are 5 types of holes that you can make. So counter bore means it is an extra diameter hole that is given to the actual hole on the upper side. We will discuss the all types of holes in the following exercises. For now I'm skipping this. And the next thing is, you can see here the symbol that is called a sectioning view. So with reference to a plane, you can cut the 3D part. So it is just for visual purpose, so it is not actual process to cut the part. So this is about sectioning. Okay, see, now I have created a hole, one type of hole here, and I want that part, that hole on the above and below. So I want these holes, 3 holes on this side, and one hole on this side and one hole on this side. So it is like a pattern shape. So for that you can draw the holes, but it will take some time. So for that you can choose a procedure for that, which is a rectangular pattern, and choose the feature, that means the hole. Here it is selected the current holes. See, I have selected this hole, so you can choose the hole from the specification tree as well. So here, okay, so instances I need is 2, no 3, okay, and reference I'm choosing this one side of the rectangle. So is here you can see I can give the gap as well. So update the value, so we click on the preview, so it is still it is nil. So I'm increasing the value, so now it is okay. But if you see, the pattern is started from our hole, that's why it is becoming outside. Now I want to start from the upper side. So what I do, I will click on the more, and you can see position of object in pattern, so row in the direction. So I want that first hole to be upside, so simply I'm updating to see how it has. Now okay, now on the second direction you have to choose the reference. Click on the second direction and choose the reference as this line, and update the instances that you need. So you can choose the arrow by your need. So I'm giving the 3 input. See, they are crumbled with each other, so I'm updating the value, so 50. So here, see, so this is the use of this rectangular pattern. Next is the 3D mirror. Here it is, and click on the command. Okay, so now select the object that you want to mirror. So I'm selecting the hole, one hole. So here I cannot mirror the pattern. So okay, I'm choosing the hole from the specification tree, and I'm choosing this a plane, mid plane. So click on OK. So here you can see, based on the mid plane mirror, a hole is generated on the other side. So this is the use of 3D mirror. So now we are discussed about rectangular pattern. Now it is time to learn about a circular pattern. For circular pattern, you need a circle thing. So okay, so I choose activating this circular command tool and choosing this parameters, and choosing this body, and reference I'm choosing this circle. So what is just happened, so I'm getting the instances that I need. So see, based on the circle that I've given, the bodies are transformed. So this is the use of the circular pattern tool. If you want the holes also transformed, you can use the circular pattern as well. So that's it guys. So most of the all commands are completed till now, so it seems like completed. So if anything else means, we can cover in the exercises. Thank you.